Okay, so this week we're working on experiment 21, which is the quantitative titration of Grignard reagents. So Grignard reagents are generated from the corresponding alkyl halide. And as we talked about in lecture today, they function as carbon-centered nucleophiles. One drawback of Grignard reagents is that Grignard reagents are quite basic and as a result can react with acidic functional groups and can be quenched by acidic functional groups. So as a result, the glassware used for Grignard reactions must be kept oven dried, and we generally use a drying tube to further remove water from our reaction atmosphere. Any water present in the air or on your glassware will react with your Grignard reagent and will consume your Grignard reagent. Now, as a result, whenever we make a Grignard reagent, we may not get 100% quantitative yield of actual usable Grignard reagent in solution. Some of it may be lost due to reactions with water, due to reactions with oxygen, and due to other side reaction processes. So when we prepare our Grignard reagent, for lab 21, we're going to prepare the Grignard reagent of 1-methyl-butyl magnesium bromide from 2-bromopentane. We're going to prepare this by reacting the 2-bromopentane with magnesium in the presence of an iodine catalyst in ether. The ether is really important because it coordinates to the Grignard and modulates and stabilizes the Grignard. So we're going to generate this Grignard reagent. And to talk a little more about the mechanism for how this Grignard reagent is formed. So as we talked about in lecture, the first step is a reduction step. And then after the reduction step, we have a combination step. This is a rare case where we have a radical reaction that is not a radical chain process. So in terms of practically how are we going to prepare our Grignard, the first step is to activate our magnesium. So first the magnesium is sanded so that the surface has been freed up and we have reactive magnesium on the surface of our magnesium ribbon. Then we'll also be treating our magnesium with a trace amount of iodine. This serves to activate the iodine and iodine surface and helps facilitate efficient formation of our Grignard reagent. Now, the Grignard is actually generated at slightly elevated temperatures, around 40 degrees Celsius. And so when we have our magnesium iodine mixture in ether and we add our Grignard at elevated temperatures, it's important that you add the Grignard slowly because the actual Grignard generation and initiation is exothermic. So by adding the Grignard slowly, we can check for a reaction, observe the exotherm, and then add the remainder of our Grignard reagent slowly. If we add the Grignard reagent all at once, we could potentially end up with a runaway exotherm. And if our mixture reaches too high of a temperature, then we often end up with degradation or undesired side reactions. So once we generate our Grignard reagent by mixing our alkyl halide with the magnesium iodine mixture, we'll end up with a solution of our Grignard reagent, which is 1-methyl magnesium bromide in ether. Now, in order to figure out the theoretical yield, we're first going to use the given amount of alkyl halide and the stoichiometry for our reaction to calculate our theoretical yield of Grignard reagent. To determine the actual yield of Grignard reagent, we're going to utilize the technique of back titration. So first, we're going to take our Grignard reagent solution and we are going to add a known and defined amount, roughly 5 milliliters, of 0.1 normal sulfuric acid, not molar, normal sulfuric acid. The sulfuric acid will react with our Grignard. Note this is a 2-to-1 stoichiometry. Grignards are bases that can accept a single proton. Sulfuric acid is a diprotic acid. So we'll generate 0.1 normal is, so normality is, oh, sorry, just to, yeah. So I believe in the video, we modified it and we used 0.2 normal, which is equivalent to 0.1 molar. The exact concentration of sulfuric acid, you're going to need to record from the video. And you can actually even use 0.1 normal and it would work perfectly fine. You need to record the exact volume and molarity of sulfuric acid used from the video, just because it's added based on the amount needed to quench and have excess sulfuric acid remaining. So also our sulfuric acid and Grignard will react, and only some of the sulfuric acid will react and completely consume our Grignard reagent. So then we would have some sulfuric acid left over. And we know that the moles of sulfuric acid left over in excess are equal to the moles of sulfuric acid added minus the moles of Grignard that we have floating around in our solution that reacted with our sulfuric acid. And because one equivalent of sulfuric acid reacts with 2 equivalents of Grignard, we have to convert the moles of Grignard into the moles of sulfuric acid that react with our Grignard reagent. Thus, by figuring out the moles of sulfuric acid added and the moles of sulfuric acid remaining after we quench our Grignard reagent, we can figure out the moles of Grignard reagent that we have generated in our solution. To figure out the moles of sulfuric acid remaining, we're going to take our leftover solution of sulfuric acid. So whatever's sitting in the solution after reaction with our Grignard reagent, we'll have only excess sulfuric acid sitting around in that solution. And we're going to titrate our excess sulfuric acid with sodium hydroxide. We're going to titrate our excess sulfuric acid with sodium hydroxide. And just like before, we have our excess sulfuric acid and reacted Grignard solution. We're going to record the initial volume, and we are going to add sodium hydroxide until we reach the end point. When we see a color change for our indicator, we'll record the final volume, and then from the volume of sodium hydroxide dispensed, we'll be able to determine the moles of sodium hydroxide, and in turn, we'll be able to figure out how many moles of sulfuric acid were left over. Once we have this information, we can use the moles of sulfuric acid left over to calculate the moles of Grignard. Once we have the moles of Grignard, we'll be able to calculate our percent yield. So does that overview make sense for today's lab? We're generating the Grignard from 2-bromopentane, and then we're titrating we're neutralizing our Grignard with sulfuric acid, and then we're back titrating the excess sulfuric acid. Any questions on this laboratory? Okay, so we'll pause this recording.